zk proofs allow you to, or allow a network or a protocol or any system to do a computation once, and no matter how expensive that computation is. And then you get this small proof that's small in so many ways. It's small in size, which means you can send it around the internet quickly. And it's small in the sense that it's really efficient to verify. So it means even if the computation was really expensive to run, we can verify that this computation ran successfully very quickly. And so you can take that and say, okay, that means I can do all this work. I can do all the work in the world. And with a few extra tricks, maybe you need recursive proofs. This is at the heart of Mina. You can eventually take all of that computation and bring it down to one single proof. And honestly, like you can't scale, and you can't really scale networks real decentralized way without this technology.
Welcome to Just the Metrics podcast. Today, I'm having a conversation with Brandon Kase. Brandon is the CEO of Owen Labs. Owen Labs is a company that is focused on advancing zero-knowledge technology, and the main company that is focused on building Mina Protocol. Mina Protocol is the first zk-native blockchain, meaning Mina Protocol leverages zero-knowledge technology for scalability, programmability, and privacy aspects of that blockchain. This conversation has given me personally a lot of perspective on what zero-knowledge technology could do for the blockchain space. And I must say, this is so far the favorite conversation that I ever had in this podcast. So without further ado, let's dive into this conversation with Brandon. Welcome to Just a Metric podcast, Brandon. Because of ZK technology being the core technology that could realize the promises that has been made in the Web3 and blockchain space. This is one of the conversations I was so much looking forward to.
Thank you. Yeah, I'm so excited to be here too.
Yeah. And in this episode, we are looking forward to talk about ZK tech, the promise of ZK and Web3 space, and Mina Protocol, the vision of Mina Protocol, and much more. But before that, I'm really interested in knowing about your career path, being a blockchain protocol dev and working with Mina Protocol, and now being the CEO of Owen Labs. Could you please talk about your career journey, your personal journey, and what drives, what's the passion behind that journey?
Yeah. So I guess on the passion side, there's like two pieces. One is just this like engineering focus that I have, and I'll get into that. But if I go chronologically, I should talk about the cryptocurrency story first. So what got me into blockchain and crypto? I saw there was a post about Bitcoin on Slashdot in 2010 that I saw, and I was like, oh, this is cool. And I tried to install it on my computer or my parents' computer, and I just couldn't get it to work. And then I remember like when Bitcoin hit $1, and I'm like, oh, like I'm missing out. And then in 2011, in the summer, when Bitcoin shot up to $15, that was crazy. It was like, I was like, I need to mine this. Like I missed out when it was $1. Like I'm not missing out anymore. And I was at an internship that summer at Qualcomm, and I was earning money as like an engineering intern. So I spent all that money building a mining rig, a desktop computer with some GPUs in it, which was competitive at the time in the BTC mining world. And then in my dorm room in university, we didn't get charged for electricity. So I just got free money as a student. And so I mined a lot of Bitcoin, storing on my hard drive. I deleted my hard drive. I deleted like 120 Bitcoin or something. And then
wow. Crazy.
Which at the time, it still was like a good amount of money for a student. It was like $1,000. It was like a couple $1,000 worth or something. It's worth a lot more now, obviously. And then, so then I'm like, okay, I can't trust like myself storing this on my machine. I'm going to store it in the cloud and in the most reputable exchange in the world, which in 2012 was Mt. Gox, which I don't know if this happened a long time ago now, but in 2014, Mt. Gox admitted to being hacked and they went bankrupt and all these things. So I lost a lot more Bitcoin, but I was into it. It was cool. I was annoyed at that point. So I didn't really pay attention in the crypto space for a while. So I missed on some of the ICOs and things, but I participated in the Tezos ICO because they use OCaml, which is what we also later decided to use for Mina. And then I started in late 2017 doing nights and weekends alongside the two founders of O1 Labs, Evan Shapiro and Isaac Eckler. And this is just to clarify how the Mina ecosystem works. O1 Labs was the company that incubated the protocol. And at the start of things, there was just O1 Labs. when Mina launched for Mainnet, ON Labs split into Mina Foundation and ON Labs. So we cut the company in half. And then the original focus of that split was the technical, like engineering and product side would stay at O1, and the everything else, like the marketing community functions, would go to Mina Foundation. And then Mina Foundation's goal is to steward the protocol, control the grants, and all that kind of stuff. And since then, the two teams have staffed up again in the different sides. But yeah, like at this point, whereas we started with O1 Labs being the only one in the Mina ecosystem, now there's Mina Foundation, ON Labs, and a bunch of other really interesting companies. I started like actually doing the protocol engineering, and then we hired a bunch of really smart protocol engineers. I first started like ramping them up, and then became a coordinator, manager type person. I realized we started to need to think about product. So I acted like a product manager. I led the project engineering team that we eventually started and grew. And then we hired like a great engineering manager. And then I switched to doing more dev pro. When we started the project, we had some ideas, but we had to adapt to how the space was evolving. And certainly as I started, I basically just filled different gaps in the organization as I found them. And I suppose that's what led me eventually to the CTO and now CEO of the company, just filling in all those gaps.
Starting from 2018 till now, it's a fantastic journey.
Yeah. Wow. It's been 6 years. I'm so passionate about all the stuff that's going on in the space. If I were to boil it down, I think at its core, it's like decentralization, which you can define in all these different ways. And I feel like the way that I work, the way that we work at O1 Labs, and the way that Mina works are all different versions, different reflections of this decentralization concept.
So the important part is the idea that zk is the core enabling technology that would make the promises of blockchain and Web3 into realities. I have read about this concept of scalable, verifiable computation, and zk is the most, as of now, the most viable way to do that. So why zk, and what is the future with zk, and why is so promising, especially in the space of blockchain, even AI? And so what is that dream?
Yeah.
Could you break it down?
Yeah. Wow. Big meaty question. So yeah. Okay. Yeah. So ultimately, the reason why zk is such a great solution or a great technology to power this scalable, verifiable computing vision, which I'll summarize in my version of understanding as being able to do anything that the normal traditional computing infrastructure can support. You can handle as many transactions and as fast as Visa, but you can still do it in this like decentralized, trustless. Why does zk make sense for this? zk proofs allow you to or allow a network or a protocol or any system to do a computation once. And no matter how expensive that computation is, it's a little bit more expensive to do it in zk, but you do it once. And then you get this small proof that's small in so many ways. It's small in size. It's small which means you can send it around the internet quickly. And it's small in the sense that it's really efficient to verify. Succinct is what we like to say. So it means even if the computation was really expensive to run, we can verify that this computation ran successfully very quickly. And so you can take that and say, okay, that means I can do all this work. I can do all the work in the world. And with a few extra tricks, maybe you need recursive proofs. This is at the heart of Mina. You can eventually take all of that computation and bring it down to one single proof. And honestly, like you can't scale, and you can't really scale networks real decentralized way without this technology. If we look at the existing systems in the blockchain space today, we pretty consistently see a trade-off between, for the ones that aren't using zk, we consistently see a trade-off between the performance and the decentralization of those networks. Depends how you define it, but yeah, and zk lets you break that trade-off space in a lot of ways. But yeah, where's Mina's place in this? As you said, like is the only, certainly the first, and I think still the only, like zk native L1 blockchain. If you think about this end game, as Vitalik calls it, or the end of the scalable, verifiable compute vision world for the solution that uses zk, in a way, like Mina is starting there, like in putting its foundations in that space, and then working backwards to add more performance and all these things that are nice for usability. Whereas like other systems like Ethereum are starting way on the other side of, okay, they have a thing that works and it runs on all the different nodes in the network and they communicate with each other, and then slowly working towards this end game. What were we thinking at the time when we made Mina? Like, why did we choose to make Mina a zk native blockchain? Because if you think back to end of 2017, early 2018, to my knowledge, there were very few people who were thinking about zk. At one point, I think that 30% of all the people in the world who like had worked with zk were like at O1 Labs. So it's funny because at the time, like zk was used prominently in Zcash for privacy purposes, but no one had used it for scalability purposes. And I remember every time I was talking about Mina to anyone, even the most technical people, you always had to start with, okay, what are zk proofs? Why are they interesting? All these things, even to people who like should be zk experts, but like, why did we pick this? zk. So being zk native, like the core piece is not just zk, it's recursive zk. So the way Mina works is a very quick version. We can go into more detail if you want, but is we have a proof of a block, of the first block. And then when we add another block to the blockchain, we make a proof that all the blocks before it were valid. We verify the last proof and then make a new proof that extends by one more block. And the metaphor that I've always liked for this is if you take a picture, like with what is it called? Kodak camera? I don't know.
Yeah, Polaroid camera. Yeah.
Polaroid. That's what I was looking for. Yeah. So imagine I'm taking a picture of you, like with a Polaroid camera, and then that prints out, and then I hand you the picture, and you hold it in front of your face or something. And then I take another picture of you. This second picture, it's the same size as the original one. It's evidence. It's a proof that two pictures were taken. And I can repeat this process. I can give you that picture. I can take another picture. Now I have evidence that three pictures were taken, and so on and so on. And eventually, like you'll have to use a microscope to know how many pictures there are. But using recursive zk snarks and the technology that we have in Mina, which I'm sure we might get into in more detail, we can do this in effectively an infinite number of times. And so Mina's blockchain is always this small, tiny thing. And that at the time, there was a lot of conversation about, blockchains are getting so big. If a blockchain is more performant, then its space usage grows faster. Then what are we going to do? How are we going to scale? In order to make blockchains faster, we have to be more centralized. These are the kinds of conversations that were happening. We're like, hey, if you use recursive zk, like we get the best of all the worlds. And it turned out you actually get so much more than what we originally thought.
What is the current state of zk technology, considering the last 6 years being able to build on top of this technology?
Yeah, it's so interesting. This space has moved so much because there was this huge explosion I noticed it in the end of 2021, or was it it was 2022. Sorry, the end of 2022. There was this sudden shift where suddenly there's not just one or two or three or four companies building with zk in our space. There's 1 or 2 or 3 or 400. There's conferences that are overflowing with people who are all experts. There's at big events, there's not just one, but several zk focused side things, or even parts of the main event. And so because of that, like the technology has evolved very quickly. So when we started, there was like recursive zk snarks, recursive zk proofs were nascent. There was like one way to do it. Like there was like one research paper, and then we used that as a starting point. We started like building on top of it, and slowly more and more papers came out about, here's how you make a proof system that goes faster. Here's how you can do a trick to get more like traditional compute in, lookup arguments. Here's like other ways to do recursion. I love like how recursion has evolved in zk because that's something that's so core to Mina. So on that track, there's this like, it's called like pairing based cycles of elliptic curve style recursion, which is like what we used initially. And initially the elliptic curves that we're building on were like 768 bits wide. The smaller you can get that, the more efficient you can get. If you're too small, then you have security problems. We've been tracking the research and like pulling in the things that make sense. We use the pasta curves, which were discovered by the folks at one of the Zcash companies, the foundation, I think. And
electric coin, I think. Coin. Yeah.
Electric coin, I think. Yeah. And that's like a 255 bit curve. So that fits computers like 256 bits. That's 8 bytes. That's a pretty good one. And it's secure enough. There have been more improvements where like people are actually using 64-bit curves or maybe even 32-bit. I'm not sure, but like much smaller ones. And then there's little special tricks you can do to get the security back. And then there's even, and this is very recent, but there's a team, Olvatana, I think is how you say their name, and they've proposed this Vinius proof system where curves are 1 bit. So it's just, okay, let's just go down to 1 bit and we can do all those tricks to get the security back. And then computers and digital circuits are really good at 1 bit. So there's like shrinking the size. That's one angle. I guess that wasn't recursion. Then on the recursion side, so one thing you can do is, and this is slower than what Mina does, but there's this new renaissance of zkVMs. Or like traditional compute zkVMs. So the way that you define zk programs, the most straightforward way, or the most way that's aligned with how the technology works, is you define what we call circuits. And they're equivalent to, not equivalent, they're like metaphorically similar to digital circuits or analog circuits in electronics. And so we call them zk circuits. But they're also similar in the sense that you can define like a CPU, like you're actually defining how the CPU works, or you can build a virtual machine, which effectively means like you're fixing the CPU, and then applications or software infrastructure that you're building in zk, you define in the application level language that's running in the virtual machine. And that's similar to like how you have a CPU, a processor on your computer, and you have programs, software that people write in Rust or C, or that eventually run on that CPU. And there's custom zkVMs that folks have created. And then now there's more traditional compute zkVMs where you can run traditional computer code and compile them into a format that runs like more efficiently inside zk. So RISC-0 is like the first company that made this reality for their RISC-V instruction set. At O1 Labs, we have a MIPS, MIPS, which is an old kind of processor architecture, a MIPS VM, which we're using, which we can talk about later. But then, so one way to do recursion is we define the code for recursion in software. So we can just take that software that we wrote, that we're running on our computers, and then compile it to the zkVM, and then put the zkVM back into the zk proof system. And then you have this kind of recursion. So that's one thing, although it's slow. There's some tricks to make it faster. And then very recent, I guess a year old now, there's been this new kind of thing that's like recursion called incremental verifiable computation, or folding. And folding is another different way to do recursion where the benefit is I don't want to get into how it works, but the difference is with folding, you define your operation. You say, I want to run this operation a bunch of times, and it's really fast. It's like way faster than other kinds of recursion. And because of that, like we're pulling that into our proof system, and we can talk about that later, but there's trade-offs. Like the recursion you get from folding, you have to, like one trusted entity has to do all of the work all at once. But traditional recursive proofs, each step of the operation can be done by a different person. So you can get, or a different trusted actor, one person or one team, and we need that for Mina because, and there's a lot of applications where you need that, like video games too, we can get into it. But for Mina, each block of the blockchain needs to be built by a different person or a different wallet address, and they can't collude with each other. So we need to be able to have different actors that don't trust each other, being able to build blocks on top of each other. And so we need to use a form of recursive proof that lets you actually do each step with a different person. But then within a block, there might be some interesting ways that we're thinking about applying folding. Anyway, this is just a sneak peek into this really cool world.
Going back to the initial topic of CK and then the vision of Mina being CK native, not only scalability, but privacy, programmability, and everything comes into this. So in that case, the vision of Mina, like everything hinges upon CK. So what do you think about that vision?
I think you're right. It's all coupled together. And once again, this is another place where we went backwards with Mina. We started at the scalability side, and now we're working backwards to privacy. So I'll go into more detail here. As I was saying, like we had this small single proof that stands in for the blockchain. This is like a scalability solution. And we're still paying attention to performance improvements. We're pulling in research. We're optimizing. We're doing all these things. But what we've been working on, which we'll get into, but is bringing like more programmability into Mina. So I guess I didn't mention yet, Mina's been on Mainnet since early 2021. And we've been working hard for part of the time in between on this, adding a programmability layer.
Why did you focus on the scalability part? Is it because of the way Ethereum approached CK, like mostly because of the scalability? Is that why Mina also focus on scalability using CK? Was that vision, or do you think scalability is the most important part?
Well, for what we believe, what I believe, what we believe in the Mina ecosystem, I think I can represent that is you can't compromise on decentralization. So why did we start with the scalability solution? We saw there was a scalability problem in the blockchain space back in 2017. We didn't see a programmability problem at that time. There weren't any applications that people were there. Like DeFi wasn't a thing for years after that. And rather than scaling, the approach we took was this like moonshot of, hey, let's build the foundations of a system that we can scale that will always be decentralized. It's decentralized immediately. It's not decentralized later when we get to it. It starts decentralized and it's always going to be decentralized. And the only way to do that at least at the time, is zk and recursive zk, of course. So it's more, it was more a decentralization thing than a scalability thing. It was like, okay, we need a core that's decentralized. And then how do we set ourselves up so that we can scale? And how do we set ourselves up so that that we push this decentralization, not just in this theoretical space of, oh, maybe we'll be decentralized in the future, but like we're decentralized now. Node operators that are running nodes get to participate in this decentralized network. And users that need to like access information about the chain, they can do so in a fully decentralized way without being a technical expert. I get to find myself jumping to a slightly different topic here, but like there's this problem, there's this centralization concern in the blockchain space that people don't really talk about. But like when users are interacting with crypto systems today, whether they're doing DeFi things or social, anything, they're relying on an RPC gateway. So like your web browser doesn't know how to talk to Ethereum directly. You need something in between that's running an Ethereum node and that's interpreting your requests that are coming from your web browser, let's say, into requests that can go to the Ethereum network. Now, you can run one of those yourself as a user, but it's extremely technically complex. So you have to set up your own computer. You'd have to run the software. You can sacrifice some decentralization. There's services that help you spin up these nodes and run them, but then services are controlling it. And then ultimately, if you don't set up anything, by default, you're using a public that's shared between a lot of users that's a centralization point in the system. But with Mina, because the whole network is this tiny proof, we can have full node security in a web browser. One usage of that is like users who are interacting with applications in their browser using zkApps. We call them zkApps. You're actually running, this is in progress. There is a usable demo, but it's not fully live yet. It'll come soon. But like you can have a full Mina node running in your web browser. The user doesn't even know it. All they care about is accessing their application. Like they want to do what they're doing. They want to trade on a DEX. They want to play a game. They want to send some messages in a social product. But like under the hood, they can actually do that in a fully decentralized way without needing to set up a node, without needing to set up this crazy RPC gateway, just because Mina is running in their web browser, like real Mina. And I think that's really cool. And that's like one of the properties you get from this system, this like decentralized core.
That is this succinct part, like 22 KB or something, right?
Mm-hmm.
That is just decentralization in the sense that trust but verify, and these verifiable proofs are very light. So basically, that means that you have designed a system which can have the maximum amount of decentralization from that sense, that it is very light to do it. Because one problem is that Bitcoiners will tell you that, oh, you should run a Bitcoin full node. But the problem is that, and people are not going to do that. Like it's at least, things would fall into the lowest common denominator. And that's why I don't think it will work when this system gets really big. And even for Ethereum, in that sense, you have this vision from the beginning because it's decentralized from the beginning onwards.
Yeah, I can talk through how the vision, like I said, like we started at this end and we're like moving backwards towards privacy, but we flipped the direction for normal zk in the same way we're like moving backwards towards building this more interactive system for users. So and we found that like this design that we have actually works really well in that world too. And the thing that's cool is like this one Mina proofs, we can prove everything. We can prove any computation that runs on Mina, it's proven and it's folded in, it's like recursively combined into this one Mina proof that is a proof of everything. And so the cool thing is like this one proof of everything that you can do cool things with privacy, you can do cool things with identity, cool things with scalability and like integrity of compute. And we can talk through all these things with this new upgrade of Mina that we've been working on. And all of that is all accessible and referenceable from this one proof. And because of that, yeah, like you can get it to people's web browsers very efficiently and very safely in a decentralized way. You can get, if you build a bridge, like to another chain, the bridge actually can verify that one proof of everything. And effectively, it's like running a full node of Mina. Like on chain, on a different chain, we can run a full node of Mina. And we can access this proof of everything. We can access this information about stuff that's happened in the zk world. Like in a way, like you can think of this platform, this Mina platform has this like zk, this universal zk layer where you can put anything, applications in, you could put L2s, L3s, ad infinitum on top of it and do anything in those places. And all of those get folded back into this one proof of everything.
Oh yeah.
And that's something that we're also really excited working towards.
So in that sense, what are the upgrades that is happening on Mina?
So Mina's mainnet came in 2021. And at that point, this is something that we forget sometimes, even like ourselves. But because we've been working on so many other things, which I'll get to later in the answer, but we're like a lot of other projects in this space are working towards their first mainnet. And it's something that we're really happy to succeed and achieve at. It's something that both ON Labs and Mina Foundation team, and I think the whole Mina ecosystem is really, really proud of. And as part of that, so there's Mina itself, but at the core, there's this proof system at the heart of Mina, which we call Kimchi as the proof system, and then Tickles is the recursive layer. And even a little bit before, we built this SDK for working with zk that we had to build ourselves as part of Mina, like to make Mina, because Mina does all this crazy stuff with zk. And at the time, there were no tools that were powerful enough to allow us to do the things that we wanted to do. We've been working on zk tooling for 6 years, basically. And we took our tools that we were built for ourselves as part of Mina, and we converted that into what we call O1JS, which is our framework for building zk applications. And that's designed for both giving the power of our proof system to the users, like exposing all the little details, all the power, the recursion, making that super easy to use, and making it intuitive and user-friendly and a good starting place for developers who are new to zk. And because it's TypeScript, you can think of it like a framework inside of TypeScript. Like beyond recursion, you can also use this proof system feature called custom gates, which are like hardware accelerators for certain things. So like we have bitwise arithmetic gates and foreign field arithmetic, it's called, but it lets you build nice things on top, like ECDSA or Ketchak verification, which again lets you access information from other blockchains from in the zk world. And because we have this, we've been growing this huge like developer ecosystem. And at this point, because we've been building our tools for so long, we had these early adopters that were really passionate and great. We have a bunch of experts in the ecosystem now that are starting companies and that are mentoring other people. So the ecosystem is like virally exploding, where ON Labs are not the only ones that are like teaching developers how to use the tools. And like it's something the Mina Foundation and the Mina ecosystem is doing like a really great job of. So what else have we been working on? We've been adding this programmability layer into Mina. It's to enable this thing we call zkApps. So it's dApps with zk. And we're so close. I think Mina was the first zk native blockchain launch. I think it will also be the first mainnet zk blockchain that has programmability, zk programmability. We just finished the biggest phase of our testnet, our incentivized testnet, which...
For interrupting.
Please.
What do you mean by zk programmability? Like when you say Mina would be the first blockchain with zk programmability, what do you mean by that?
I mean that, okay, so programmability, what do I mean by that? You can write smart contracts that do interesting things. And zk programmability is weaving into the core of the smart contracts the superpowers of zk. And ultimately, there's two superpowers: privacy, which we haven't talked about yet, and then this kind of like integrity of compute, which lets you do things with scalability and other interesting things. And I'm happy to give a few examples of those if you'd like.
Yeah,
but
please go ahead.
Okay. And I should say our system of zk programmability, we had as a design goal that we wanted anything that you could do on the EVM, we wanted you to be able to do in Mina, in a Mina smart contract. So you can do anything that you can do in EVM, plus you get privacy and this compute integrity power that you can weave in. So let's see. So privacy, I'll just throw out some interesting use cases at a high level.
Yeah.
You could do proof of membership in a group. So you could say like, I own a Bored Ape NFT, but I'm not going to tell you which one. And that'll add me to some secret group chat or something. You could have like you could do the same thing with like your Web3 activity. You could have proof that I'm a real person to do like anti-spam things. You could have a proof of a Web2 credential. So you could bring Web2 data into the Web3 world. This is something that I find really interesting. You could do something that's so wild, that's like way different from anything that people are building in blockchain right now. You could say, I have a proof that my data that I control, that I'm keeping private, it has these certain properties. For example, I have knowledge of a drug that when I apply this drug to some proteins in the human body in a simulation, it cures this disease. And I could prove that to you without revealing how the formula for my drug. And this is something that will be like immediately useful in like the pharmaceutical industry, for example, because right now there's this like whole complicated thing with brokers and all these things. So anyway, there's a few stuff on the privacy side. On the integrity side, so there's all the scalability stuff. So as we talked about, it's useful for building L2s and L3s and little app chains, things like that. But you can also use it, for example, Oracle calculations. So rather than, for example, Oracle having to dump like every data at every point in time and fill up block space, chart, like it'll cost a lot of money. You can just have some data off chain that is coming from a secure place, which could be on another chain, and then compute with it and do some calculation that compresses that down. It takes the average over a time window. And then you just post that average to the chain. And then, because maybe that's what something is. Or like I'm playing a game, like a casino game, and I want to make sure like no one's cheating. There have been these stories of the operators of gambling websites, like looking at the hands of the players when they're playing these kinds of games. Like I guess there's some privacy in there as well, but ultimately what you need to do is you need to prove that you're following the rules of the game using the data that you have locally, because we don't want the players to cheat either. And then you submit a proof to either another player, if you use recursion again, or to some. So anyway, I hope that kind of paints a picture of what I mean by privacy and integrity.
So one of the topics that really like trending right now is AI. It's exploding right now, starting from ChatGPT to all use cases in companies like Perplexity, building cool solutions. But the thing is that the quality of whatever these AI models will generate depends upon the quality of the data. And the data with the most quality would stay private until and unless you have a solution to use that data without exposing the sensitive details. Especially me having a background from medicine, I understand that to use patient details and other details that could actually progress the medicine really ahead, you need that data. But for some machine learning algorithm to use that data, you will need some solution that as an intermediate system that would prevent sensitive data from being misused. In that sense, zk, I believe, would be a core enabling technology. And from the context of Mina being a layer 1 blockchain, combining blockchain, zk tech, and looking at AI, where AI is going, what do you think about such use cases? Is this also part of Mina's vision?
Yeah, this is really interesting. So there's a lot of places in which zk can provide interesting features to AI systems, to machine learning systems. And in different places, there's more viable now, and some are more like we need a little bit more technology to mature before we can actually practically use them. And and of course, we want to see people use them on Mina too. So okay. One way is what we call like proof of model. So the idea is the model is trained somewhere, and that's out of zk world. So there's a separate problem of like, how do we get zk in the training space? But then there's a zk proof that we're using a particular model to infer something. And this can be used for companies can make sure that they're actually getting what they're paying for. For example, but a team like keeps things private. What is AI doing? It's looking at a bunch of data in the high dimensional space and like finding clusters essentially. And then you interpret the output. So like a linear regression is like a very simple model. And that's something you can do today easily, efficiently in the zk system. Now there's to do more fancy things. And I agree with you. There's interesting things you can do. So like train models on your data without your data leaving your custody. And then you have the zk that proves that data was actually used and was used the right way. Those kinds of things are like, they're already slow out of zk. So I don't remember off the top of my head, OpenAI spent God knows how many compute hours on GPUs. And that's outside of zk. So if you're putting, when you put things inside of zk proof, your compute slows down. So you can't really train like these sophisticated LLM models right now with the performance we have with zk. But we are starting to see proof systems that are designed specifically for high performance AI, high performance like matrix operations, which effectively leads to machine learning, high performance machine learning things. And this is something that we're keeping our eye on for maybe pulling in some optimizations into our proof system directly. But the thing that we're more likely to do, and something that we're already exploring in a few different places, is we want to bring these custom proof systems into Mina through a adapter layer. So like the Mina's core proof system with kimchi and pickles, it's really good at recursively verifying itself. But it turns out that also means it's really good at verifying other proofs in other proof systems. It's a little bit harder and you have to do different kinds of things, but we believe that for certain kinds of niche applications that are really important, like machine learning, people will go really deep. And like I said, this is already starting into building proof systems that are super good for machine learning training, let's say, but like really bad at everything else or have all these other properties you don't want. But we want our application developers to be able to say, okay, I want to put this AI component into my application, but I also want to do all these other things. And maybe I want this other component that's specialized in a different way. And the metaphor here, the analogy to typical computer systems, like I have a general purpose processor on my computer, and then I have a GPU, which is just for graphics. So you can think of the GPU for my AI proof system, or TPU. That's the Google one. I have my dedicated proof system for AI. I can verify that within Kimchi, and that means I can take proofs that I create with this other proof system and use them inside my zkApps. And then I can build applications on Mina that use these features. Yeah. So it's something we're keeping our eye on. It's actually a year ago, it was like much more, I was like, this is a long way away. And now, I don't know, getting closer. And I'll say, when it's ready, like we definitely want to make sure that it's compatible and people can use it to build cool stuff.
That sounds great. Now, like moving a bit to the privacy part, what is the status of privacy in Mina right now? As you said, like you are moving backwards towards privacy from where it came from. So what is the status of privacy from terms of Mina?
When in an upcoming hard fork, should the community choose this particular fork, we'll have this full programmability, like in the terms of power of what the EVM can do, plus privacy. So what we've done is we've put privacy into the application layer. So at the core layer of Mina, things are transparent. And this is nice for a lot of reasons. But at the application layer, you can do anything with privacy. So there's already a few people in the ecosystem who've built a private transaction layer. There's an L2 that's just focused on privacy that some folks are working on. So I would say like the issue with privacy by default is that it makes everything more complicated. So it was a design decision for us to say, okay, the core needs to be transparent because we want lots of applications on Mina, not just everything is private. But of course, we want to support applications that do all sorts of interesting things with privacy. And so this is why we've decided on this system.
Okay. So privacy would ultimately depend upon the programs that would decide to use or not use the privacy aspect. I think that also has some regulatory implications. Because if layer 1s remain free, it won't affect the way you build the layer 1. But depending upon the apps and the regulatory regime, which geography you're based on, you can decide not or use it or not. So yeah, that's pretty cool. So to compile that conversation we had, can I say that it's like CK is going to be the most enabling part of tech when it comes to the vision of blockchain. And in that
I
sense,
certainly think so.
Mina being a CK native blockchain combines that vision of CK being the enabling tech in the Web3 and blockchain space, combining programmability, privacy, and scalability. And that vision is going to unfold through the upcoming upgrades that Mina would implement on the layer one. And I believe that Berkeley upgrade is the most important upcoming upgrade for Mina. So if you could elaborate, what is the Berkeley upgrade? What's the relevance of that upgrade?
Yeah. This is this big upgrade, Berkeley, we're calling it, that I was saying, where we'll introduce the programmability layer, we'll introduce zkApps. We finished this, are the biggest portion of incentivized testnet already. We have a tiny bit left. And just to go deeper into that, we finished the part of the testnet that makes sure that the protocol works. And in a world where there's lots of different nodes all around the world running the network, and people are trying to break it at the same time. And we were in that mode for a decent amount of time because we were finding issues, fixing them, iterating. And we're at the point where we're like, okay, that works. We're done. The only thing that's left, the only thing that we're testing now is the phase of the testnet that we're in is focused on actually testing the hard fork itself. Because this will be the first, if the community votes for it, this will be the first hard fork that Mina has seen on Mainnet. So we want to make sure that we have a test, a phase of the testnet that's dedicated to that process. So as soon as that's done, and trust me, that part of the software is a lot simpler than the actual programmability layer. It's really close, but I'm not going to commit to a date. Yeah. And yeah, what's in that? So there's this zkApp component where people can build programmable systems. We've already talked about that. We have so many stability fixes to the thing itself. I should say Mina has never gone down since Mainnet. I'm very proud to say that.
Especially in the context that Solana went down for half a day or something.
Well, it's very hard. It's very hard to build these things. No hard feelings. Sorts of them. And of course, when you introduce a programmability layer, there's a lot more surface area for issues to pop up. So as part of that, we've hardened it a lot. So there's tons of stability fixes. And then there's a bunch of performance improvements. Now, adding programmability costs a lot of performance. So we've improved the speed of a lot of things, but then we had to compensate because having programmable systems slows it down. But we've set ourselves up, we've set the foundations up so we can follow on with scalability, quick scalability upgrades. And then the other component here, which is related, this new upgrade of Mina will allow L2s to be built on Mina really easily, zk rollup L2s. And there's already two big projects in this space that are working on it. And one of them, zkApps, is a huge part of that is being built by DC Spark and led by Sebastian, who I think is your audience will be
definitely with. Sebastian, DC Spark, and Sebastian like a prolific builders in the Cardano community.
They're really terrific. Yeah, I guess zkApps lets you. It's like a mind-bending recursive. Everything's recursive in Mina. It's thing within a thing. So what zkApps is, it takes Mina. So the same interface that developers have, you still use O1.js to build your zkApps. All the things that are supported on Mina are supported on zkApps. And you can then put that as an L2 that then recursively folds itself inside a zkApp. So it's essentially the execution layer of Mina running inside of itself. And that's the zkApps thing. But what that gives you is you can inherit the decentralization of the base layer of Mina, but you can do little tricks to make some systems a little bit more centralized, but in exchange, way faster. And because you have the decentralization on the base layer, you're still secured. You still have a trusted system. So yeah, we're really excited about that too.
zkApps is also a zk rollup. So it's not...
Yes.
I have listened to one of your interviews where you called Mina itself as a zk rollup.
Yeah.
In a sense.
Let's talk about that. Okay. Mina invented, there's some caveat, but essentially Mina is a zk rollup. And it's actually a Validium. There's nuance. But yeah, we were okay, we need something that's scalable. And we came up with this design of this recursive zk thing. We didn't call it zk rollups. We didn't stick it on Ethereum first. But yeah, Mina, this process that I described of taking all the work and putting into it a zk proof, that's what zk rollup does. So yeah, so if you put Mina on top of itself, you have a zk rollup L2 on top of Mina, which itself is a zk rollup. And that's cool because like Zeko's one, there's another proto kit that has like way different design and interesting and solves a bunch of other problems. And then there's another privacy focused one that's in progress. And even like applications themselves can be zk rollups really easily. And you can stick those applications on Zeko. And then you have layer 2s on layer 2s, which is like layer 2 squared or layer 3 or whatever. And you can keep going. You can put Zeko on itself.
One important topic when you talk about layer 2s and layer 3s is the topic of composability. How easy is to transfer assets between all these systems? Could you talk about the composability part of the system with bridges and how easy would be from a user experience perspective?
Yeah. So within Mina, there's the bridge that you need to get from the L1 to an L2 and back. Then there's bridges between L2s. And then there's bridges from Mina to other blockchains. So there's like wide gamut. So from an L1 to an L2, it's just a zkApp. And it's like really straightforward. It's not even interesting to talk about. Now, the cool thing, the answer to everything is recursion in Mina. There's a really cool way in which different applications can communicate with each other. And the ecosystem is in the process of defining an asset standard that uses this process so that people can have something to work with when they're transferring assets. But this more general system that I'm going to describe works for any state. It doesn't even have to be an asset. If one application is a Mina proof and the other application is a Mina proof, then you can share state by verifying one application's proof inside of the other one. And there you go. Done. Bridged. Yeah. So all you do is you just recursively verify a proof of a different application and then you pull data from the base layer or from a DA layer or from other off-chain places and you can bridge states. So communication between applications is straightforward. It's ultimately all forms of composability in Mina at the lowest layer is recursive proofs. And even if you think about bridging to other chains, the Lambda class team is working on an Ethereum state bridge for Mina. So what that entails is it's like I said, it's running a Mina full node. Running a Mina full node is just verifying a recursive Mina proof. And when you do that, you can transfer stuff over. Now, in the other direction, that's also interesting. It's you need to run effectively like a light client of the counterparty chain. So let's say Ethereum, you have to prove that Ethereum's consensus is correct inside of a Mina proof. And that's how you go the other direction. So that direction, we have some ideas, but that hasn't started yet. But even going one way, so you could also just bridge in the traditional sense of any traditional bridge that is like multi-sig or has other game theoretic solutions. The way that bridges just work in any crypto ecosystem, that'll still work. But this super powered zk bridge, anyway, I'm really excited about it. So in short, recursive proofs, that's how you solve bridging and composability at every layer of the system.
Looking forward to that vision actually coming into reality. That's one of the major hurdles right now in the whole blockchain ecosystem. And finally, coming to as you said, my main upcoming upgrade being Berkeley upgrade. And if people want to take their first step in exploring Mina ecosystem and for developers as well as normal users like testnet. So can you give us like a small introduction? How can people get into the Mina ecosystem, explore from a developer and normal user perspective?
Yeah. The best thing to do is to join our community. So there's a Mina Discord and you can find the whole O1 Labs team in there and chat with us. You can follow at O1 Labs on Twitter. We share regular updates there and we share interesting reading materials, if it's blog posts or papers or documentation. And then the docs on Mina Protocol's website. So just docs.minaprotocol.com. They have information about how the protocol works, how zkApps work, how to build zkApps, how you can use O1JS to build zkApps, all layers in between. And there's buttons you can press that say, hey, my answer, I need something that's not here. And then we'll probably write something either to you in a message or we'll update the documentation.
Yeah, fantastic. Brandon, thank you for taking the time to have this conversation. It is fantastic. And congrats again for becoming CEO of O1 Labs. So we are looking forward to the upcoming upgrades on Mina Protocol as further innovation from O1 Labs as well as from the Mina ecosystem. So looking forward to the Berkeley upgrade. And thank you so much.
Thank you so much.
Thanks for tuning in. If you are keen on getting deeper insights about Web3 tech, our newsletter, Just the Metrics, is just what you need. It's packed with valuable information and it's completely free. You can subscribe by clicking the link in the video description. It's a great way to keep up with the latest in the Web3 space straight to your inbox. And before you go, please hit that like button and don't forget to subscribe to our channel for more updates and insights. Your support is what keeps these videos coming. So see you in the next video.